Welcome back. Let's practice simplifying variable expressions using addition properties and combining like terms. Alright, so here's our first example. We want to simplify the variable expression, and we have 3x plus 2 plus 5x. Alright, so remember, when you're simplifying variable expressions, you can combine pieces, or these different terms, when they share the same variable part. So in this variable expression, notice that both 3x and 5x have the same variable part of x. Alright, but this term in the middle, or this constant term of 2, does not share that variable part. So you cannot combine 2 with either of these two terms, but you can combine 5x and 3x with each other. Alright, since they have the same variable part, the way that we can simplify the variable expression is by adding their coefficients, or by adding the number in front of that variable. Okay, and we know that 3 plus 5 is 8, so we would say that this is equal to 8x plus 2. Okay, you add the coefficients, but then keep the same variable part. Don't forget about that x. It still stays with the result of combining those two like terms. All right, whenever you see two terms in a variable expression that have the same variable part, we refer to those as like terms. Okay, but that's it. That is as far as we can simplify this variable expression. It went from these three terms down to just these two terms, 8x plus 2. Let's take a look at another example. Here we once again want to simplify the variable expression, except our variable expression this time has a lot more terms to work with. We have 6y plus 7x plus 6y minus 2x plus 1. And so what we want to be looking for here are any pairs or any sets of like terms. You want to be looking at the variable parts of the terms in your variable expression and see if there are any that match up. And so in this case, I see that we have two terms that involve y. Those would be like terms. We have 6y and 6y. And then I also see that we have two terms that involve x, right? We have 7x and negative 2x. So if we want to simplify the variable expression, we want to combine those pairs of like terms. All right, so starting with the y terms, we have 6y and 6y. What you want to do is add their coefficients. 6 plus 6 is 12, so combining the like terms gives us 12y. Okay, and then for the x terms, we have 7x and negative 2x, so we want to combine them by adding 7 and negative 2. And 7 plus negative 2 gives you positive 5, so we have plus 5x. And so now we have taken care of all the variable terms that are like terms. The only thing we have to remember to add on to the end here is this constant term that doesn't have any friends, right? There are no other constant terms in this variable expression, so there's nothing to combine with 1. 1 just stays the same. So we just want to write plus 1 on the end of our answer, and that's it. That is the simplification of the variable expression that we were given. Next up, we want to simplify the variable expression that we have right here. X squared plus 2x plus 3 plus 8x minus 6x squared plus 4. All right, so once again, the first thing that we want to do here is just identify if we have any like terms. And so starting with the first term, we have x squared. What we want to be looking for are any other terms in the variable expression that have that same variable part of x squared. Not just x, that would not be a like term. You want to look specifically for x being squared. All right, so looking through all these terms, oh, there's one. This is the only other term that involves x squared, so these two terms would be like terms. We will be able to combine those. All right, so we have x squared and negative 6x squared that are like terms. Now let's see if we have any more. Let's move on to this term. We have 2x. The variable part is just x, so any like terms will also have just x as its variable part. All right, so looking through our terms, there we go. We have 8x. That also just has a variable part of x. So those are two like terms that we can combine. And then let's look for any more like terms. All we're left with is 3 and 4. Both of those are constant terms, so we can add them. Two constants would be like terms because they technically have the same variable part, which is nothing. There is no variable. So we will be able to combine those two terms as well. We'll just add 3 and 4 to get 7. All right, but to take this one step at a time here, let's start with our x squared terms. We have x squared and negative 6x squared. To combine the like terms, we want to add their coefficients. So the coefficient of x squared, well, it doesn't look like there is one, right? There's no number in front of it, but that just means the coefficient is 1. So we have 1 plus -6, which would be -5. All right, so we have -5 x squared. And then moving on to the next pair, we have 2x and 8x. Adding their coefficients, 2 plus 8 gives us 10. So we'll have plus 10 times x. Remember to keep the same variable part. And then finally, we just need to take care of our constant terms, 3 and 4. And as I said earlier, 3 plus 4 is 7. So we have plus 7. All right, and so that right there would be the simplified form of this variable expression. We have now combined all the like terms. And by the way, as you're practicing doing this, if it's helpful for you, sometimes I would recommend checking off the terms as you combine them. So once we combined x squared and -6x squared, feel free to put little check marks above them so that you know that you've already combined them and you don't need to come back to them. All right, that way you don't write them in the expression again. And we could do the same thing for 2x and 8x. Once we combine them to be 10x, you could check them off so you know that you have used them and they're done. And then the same thing for 3 and 4. Once you have combined those to be 7, then you could check off those two terms. And now you can see that you have accounted for all of the terms in the variable expression. You haven't left anything behind, so you know your answer should be correct, assuming that you added the coefficients of your like terms correctly. Okay, so that's just a little pointer. I might do that from here on out because we're going to be working with more complicated variable expressions that have a lot more terms to keep track of. So checking off terms as you rewrite them or combine them to get your more simplified form can be helpful. Okay, let's take a look at another example. Here we once again want to simplify the variable expression, but this time we have 8xy plus 4x minus 3y minus 7xy plus 9x squared. Okay, so just like with our previous examples, let's start by identifying any like terms. And I always start by looking at the first one. Let's see if we have any other terms in this variable expression that share the same variable part of x times y. And so looking at our terms here, 4x and 3y, they have an x and a y, but not both of them. They just have one or the other. So they are not like terms with 8xy. In order to be like terms, 4x would have to be 4xy, and 3y would have to be 3xy. Okay, so they don't have the full variable part that 8xy does, so they are not like terms. But then moving on here, -7xy would be a like term. All right, so let's box those in. 8xy and -7xy are two terms with the same variable part, so they are like terms that we could combine. And that's it. There are no other terms with xy in them, so those are the only two terms with that variable part that we can combine. Now looking at the rest of our terms, they all have different variable parts, right? We have 4x, then -3y, and 9x squared. All right, those are three unique variable parts, and so the rest of these terms are not like terms. We cannot combine them in any way. All right, so to simplify this variable expression, we're just going to add these two like terms and then rewrite everything else. All right, so for 8xy and -7xy, we want to combine their coefficients, but then keep the same variable part, and 8 plus -7 is 1. So you would have 1 times xy, but remember, you don't really write the coefficient of 1. You just write the variable part, and that represents the same thing. Okay, so you have xy, so let's check off those two terms. We have now combined them, and then we just need to rewrite everything else. So we have xy plus 4x minus 3y plus 9x squared. All right, and if you want, you could check off all of those terms as well. And so now you can see visually that we have accounted for all of the terms in this variable expression and have simplified as far as we can by combining like terms. All right, so that would be our final answer for this example. Next up, we want to simplify another variable expression. This time we're working with some different variables, but the process will remain the same. Our variable expression is 7 minus n plus 5k plus 6s plus 13n minus 4s plus k. All right, so we don't have x's and y's in this case. We now have n, k, and s, but that doesn't matter. It doesn't matter what your variables are. As long as the variable part is the same between variable terms, they are like terms. Okay, so let's try to identify as many as we can here. Starting with 7, that's just a constant term. So do we have any other constants in this variable expression? Well, no. All the other terms involve a variable of some kind. So 7 is on its own. It's not going to be combined with anything. So let's move on to the next term here. We have negative n. Are there any other terms that have a variable part of n? And if we look through our terms here, 13n also has an n. So those are like terms. Negative n and 13n can be combined. And that's it. There are no other variable terms with n. So let's move on to looking for other like terms. Here we have 5k. Let's see if there are any other terms that involve the variable part of k. And looking through our terms, we have one right here. It is the only other one. It is just positive k, which means it represents 1k. That would be a like term with 5k. All right, so we will be able to combine those when we simplify the variable expression. And then finally, what about our last two terms here? Are they like terms? Well, yes, actually. They both have the same variable part of s. So we will be able to combine 6s and negative 4s when we rewrite or simplify this variable expression. All right, so now let's actually do that. Let's combine the like terms that we have identified. First up, let's take care of 7 here. That's not going to be combined with anything, so I'm just going to rewrite it. We have 7, so I'll check that off. We took care of 7. Then let's add our n terms. We have negative 1n, that's what negative n represents, and 13n. So negative 1 plus 13 is 12. So we have plus 12n. And then I'll check off those two terms so we know that we have accounted for them. Moving on to our next variable term, we have 5k. Its like term is k, so you want to add those two terms. Adding their coefficients, or the number in front of the variable, we have 5 plus 1, which is 6. So we have plus 6k. And then we can check those two terms off. Now we have two terms left, 6s and negative 4s. Combining their coefficients, or adding those together, we have 6 plus negative 4, which is 2. So we have plus 2s. And then we can check those off. We have now accounted for all of the variable terms and the constant term in this variable expression and have simplified it to look like this. Okay, so we were able to go from a variable expression that has 1, 2, 3, 4, 5, 6, 7 terms to a variable expression that has 1, 2, 3, 4 terms. Okay, so clearly you can see that combining like terms does make variable expressions simpler. Let's take a look at another example. Next up, we want to simplify this variable expression. We have 1/2 z plus 1/3 x plus 1/4 y minus 1/2 z plus 2/3 x plus x. Okay, so let's go through the process again. Let's identify any sets of like terms that we will be able to combine. Starting with our first term here, we have 1/2 z. Let's look through the rest of our terms and see if any of them have the same variable part of z. And so looking through our terms, there's one. We have negative 1/2 times z. So those are two like terms that we can combine. Then let's look at our next term here. We have 1/3 x. And so let's see if there are any other terms in this variable expression that have the variable part x. So this one doesn't, it's y. But then these two both have the same variable part of x, right? We have 2/3 x and then just x. So that would be 1x. So there's actually 3 different terms that have the same variable part of x in this case. So we will be able to combine all 3 of them. We will combine 1/3 x, 2/3 x, and x. And then that just leaves us with 1/4 y, which doesn't have any friends. There's no like terms for that variable term. There are no other terms that involve the variable part of y. So it's on its own. We'll just rewrite it when we simplify the variable expression here. But now let's do that. Let's add our like terms. And starting off with the z terms, notice that they are just the opposite of each other, right? We have 1/2 z and negative 1/2 z. Whenever you have a term and then the opposite of that term and you combine them, it's just equal to 0, all right? It's just like with regular numbers. If you have 2 and you add negative 2 or subtract 2, that results in 0. The same is true for variable expressions. If you have a term and its negative version, they are going to cancel out and leave you with 0. All right, so actually what I like to do here is just cross those out. That's how I represent that they are canceled out and become 0. All right, so there's no need to write down 0 in our answer here because adding 0 to anything doesn't change anything. We can just cross those out and be done with it. All right, but then adding our other like terms, we have 1/3 x, 2/3 x, and x. Let's simplify by adding their coefficients. 1/3 plus 2/3 is 3/3, and 3/3 is equal to 1. So technically what we'd have here, just between these two terms, is 3/3 times x, but 3 divided by 3 is 1. So you have 1x and then plus this x, so that would be 2x, okay? So you have 3/3 x plus x, which is just x plus x, which is 2x. All right, so that's what we're going to write down for the simplification of those three terms. We have 2x, and so let's check those off. We are now done with those terms. And then after that, all we have left to take care of is this lonely term right here, 1/4 y. So let's just add that on the end here, and we're done. There's nothing to combine that with. It's by itself. All right, and so with that, that is the simplified version of this variable expression after combining like terms. Hey there, real quick, before we take a look at the next example, if you find my tutorial videos here at JK Math to be helpful, then I'd like to invite you to join my membership site, JK Math Plus, where you get access to many perks, including bonus content and my exclusive community. The bonus content includes dark mode versions of my videos, extra example problems, and more, while the community is a private space online where you can post questions, have discussions, and study together with me and other members. To learn how to join and see a full list of everything you get access to as a member, you can head over to jkmathematics.com/plus. I'll have a link for that in the description of this video. So if you are interested in becoming a member, feel free to check that out. It's a great way to support me and the tutorials I make, as well as a great way for you to learn math better. But for now, let's take a look at the next example. For our next example, we want to simplify this variable expression by combining like terms. We have 3a plus 8ab plus 2a minus 14b plus 14b minus 2a minus 8ab minus 3a. Okay, so we have a lot of terms to work with here. Don't let that overwhelm you. Just go through the same process that we have done in the previous examples. Look through the variable expression and identify any terms that have the same variable part. So starting with the first term, we have 3a. Let's look for any other terms in the variable expression that have the variable part of a. So looking through, we have 2a, that's a like term. Then we have negative 2a, that's another like term. And then negative 3a, that's another like term. So we have 4 like terms that have the same variable part of a. So let me make a note of that here. We have 3a, and then 2a, negative 2a, and negative 3a. All right, we'll work on combining those later. For now, let's move on to our next variable term and see if it has any friends, if it has any like terms with the same variable part. In this case, we have 8ab, so we want to be looking for other terms that have ab. And so these two terms are not like terms, they just have b, but this one is. Negative 8ab has the same variable part. So those are like terms, so I'll make a note of that here. We will be able to combine those as well. But then finally, we have these two terms, negative 14b and positive 14b. Both of them have the same variable part of b, so they are like terms. So I'll box those in as well. We can add those two terms together. Okay, so now we've identified all of the like terms that we have. Now let's actually combine them. And something very interesting is going to happen for this particular variable expression. Notice that we have 3a and 2a, but then we have the negative versions over here, negative 2a, negative 3a. So all of these terms are going to cancel out, right? They're all going to become 0. 3a cancels out with negative 3a. They will become 0. You have a positive term and then its negative version, so together they equal 0. 3 plus negative 3 is 0. And the same thing happens for 2a and negative 2a. They will also cancel out to become 0 because 2 plus negative 2 is 0. And then for our other sets of like terms, we have 8ab and negative 8ab. So that's just the same term but negative over here. So adding their coefficients is also going to result in 0. You have 8 plus negative 8. That's 0. 0 times ab would be 0. So the whole term becomes 0. They just cancel each other out. Then finally, we have negative 14b and positive 14b. Once again, it's just a term and its a negative version. Negative 14 plus 14 is 0. So just like with the other like terms, they cancel each other out and become 0. So the question is, well, if everything cancels out, how do we simplify the variable expression? Well, the answer is pretty simple. It's just 0. Everything cancels out, so the whole thing is equal to 0. Okay, kind of a weird example, but sometimes that can happen. You can have a lot of variable terms that cancel out and just be left with 0. Okay, let's take a look at another example. Here we want to simplify this variable expression. We have 7y cubed minus y squared plus 3y plus 1 plus y to the power of 4 minus 5y cubed plus 10y plus y squared plus 8. Okay, so once again, let's look through all of these variable terms and identify any like terms. I did notice as we read through here that there's only one type of variable throughout all the terms, and that is y, but not all of the terms will be like terms because y is being raised to different powers. All right, so in order for two variable terms to be like terms, the variable part has to be exactly the same, so you have to have y raised to the same power in order for them to be like terms. All right, so starting with the first one here, we have 7y cubed. We only want to be looking out for other y cubed terms when identifying like terms. All right, so looking through our terms here, there's one. We have negative 5y cubed, and I believe that's the only other one. So those are the only two like terms involving y cubed. So let's make a note of that here. Then moving on to negative y squared, let's look for other terms that involve a y squared. So looking through our terms here, there's just one other one. It's positive y squared. So maybe if you're looking ahead, you can see that those two terms will actually cancel out, right? Negative y squared plus y squared would be 0. Those two terms are the same term, but one is the negative version of the other. So in fact, let's just take care of that right now. Those are going to cancel out to become 0. And then moving on to the next term here, we have 3y. Let's look for other terms that involve just y raised to the first power. So looking through these terms, there we go, 10y. That is a like term with 3y. They have the same variable part. So I'll make a note of that here. 3y and 10y are like terms. And then we have 1. That's a constant term. Do you see any other constant terms? Well, yes, we have one right here. 8 and 1 are both constant terms, so we can combine them. And then that just leaves us with y to the power of 4. Okay, and that's the only term left, so there are no like terms for this term. None of the other terms in this variable expression have a variable part of y to the 4th power. So we can just rewrite this term as it is. No changes are necessary. Okay, and now if we add our like terms that we've identified, we have 7y cubed and negative 5y cubed. Adding the coefficients, 7 plus negative 5 results in 2. So we have 2y cubed. And then let's check off those two terms. We have now used them. And then we already took care of negative y squared and y squared. They became 0, so we don't need to rewrite anything there. But then 3y and 10y, 3 plus 10 is 13. So we'll have plus 13y, keep that same variable part. But then you can check off those two terms. We have taken those into account. Then we have constant terms of 1 and 8. 1 plus 8 is 9. So we have plus 9, then we can check those off. And finally, we have y to the power 4. We can just write that on the end here. Okay, and so that would be it. This is the simplification of this variable expression by combining like terms. I will do one extra step here. This is something that you will see more of later on in algebra, but typically when you have a variable expression where all the terms are of the same variable, but just raised to different powers, so we have y cubed, y, and y to the power of 4, it's pretty standard practice to write the terms in the order where the powers are decreasing. So what I mean by that is you would reorder these terms such that the highest power term is first, and then you decrease from there. The reason we can do that, the reason we can reorder these terms is because the order of addition doesn't matter, right? We looked at this in the lesson video for this topic. The properties of addition tell us that it doesn't matter what order we add numbers in, it will result in the same value. So we could say that this is equal to y to the power of 4 plus 2y cubed plus 13y plus 9. I just put this y to the power of 4 term first so that our terms are ordered from biggest to smallest in terms of the powers of y. So we have y to the power of 4, then y cubed, then y to the first power, and then just the constant term where there is no y. All right, so that would be my final answer. Again, that is an optional step. This result up here would also be correct. It is the simplification of this variable expression. This one just looks a little bit nicer. It's more organized. Okay, but that's it for this example. Let's take a look at one more for this video. Okay, so here's our last example. One more time, we want to simplify the variable expression, and this is by far the biggest variable expression that we have looked at so far. There are a lot of terms here to keep track of, so this is where checking off terms as you combine them can be helpful to make sure you don't miss anything. But let's read through the variable expression to start. We have 4a squared b plus 2ab minus 3ab squared plus 2a minus 6a squared b plus 5ab squared minus b plus ab minus 8 plus 8a minus 2b plus 10. Okay, so once again, don't let the number of terms overwhelm you. Just start looking at them one by one and seeing if you have any like terms, if any of the terms have the same variable part. So starting with the first term here, we have 4a squared b. You want to look through these terms and see if any of them have the same exact variable part. It has to have a squared and b. All right, so looking through our terms, this does not match up because a is to the power of 1 and b is being squared. That is not what we have here. A needs to be squared and b needs to be to the first power, so that's not a like term. But then moving on, here we go, negative 6 a squared b. That is a like term. So let's make a note of that here. These two terms are like terms. And then looking through the rest of our terms, none of them are like terms with these two. Okay, this one's close, but it doesn't quite match up. Again, we have a b squared, which is different than a squared b. Okay, so then moving on to this term, let's see if we have any like terms with 2ab. You want to be looking for just a and b in the variable expression. This is not a like term because b is being squared. If it was not being squared, then they would be like terms, but they're not. And then looking further on, again, b is being squared, so that is not a like term. And then here we go, we have a times b, that is a like term. So that term can be combined with 2ab. And that's it. There are no other terms with ab. So let's move on to negative 3ab squared. Do we have any other terms with ab squared in them? And there's just one, this one right here, 5ab squared. So those are like terms. We'll make a note of that here, negative 3ab squared and positive 5ab squared. And then let's move on to 2a. Are there any other variable terms that involve just a? Well, there is right here. We have 8a. So those are like terms, 8a and 2a. All right, then let's look at negative b. Are there any other terms with b in them? Looking at what's left here, here's one, negative 2b. Those are like terms. We have negative b and negative 2b, so we can combine those. And then finally, we have two constant terms left over, so those are also like terms that we can combine. We have negative 8 and positive 10. Okay, so now we've identified all the different sets of like terms that we have. Now let's actually combine them set by set. First up, we have 4a squared b and negative 6a squared b. We want to add the coefficients. 4 and negative 6 give us negative 2. So this is equal to negative 2a squared b. So we can check those two terms off. Moving on, we have 2ab and then just ab. So that would be 1ab. So ab plus 2ab is 3ab. So we have plus 3ab. Then we can check those off. Moving on, we have negative 3ab squared and 5ab squared. Adding those coefficients, negative 3 and 5, gives us 2. So we have plus 2ab squared. And then we can check those two off. And then moving on to 2a, we have 2a and 8a. So we can add those coefficients. 2 plus 8 is 10. So we have plus 10a. All right, then we can check those two terms off. And then moving on over here, we have negative b and negative 2b. Adding those coefficients, we have negative 1 and negative 2, which together is negative 3. So we have minus 3b. And now we can check those off. And then finally, we're just left with negative 8 and 10, which are our constant terms. Negative 8 plus 10 is 2. So we have plus 2 on the end there, and we can check off those terms. And now you can see visually that we have accounted for all of the terms in this variable expression. We have now combined all of the like terms and have a simplified version of this variable expression. All right, so this would be the final answer to this example. Okay, and so with that, this was the last example for this video. But if you do want to get some more practice, I have more available on my membership site. So if that's something that interests you, feel free to look into becoming a member. You can get all the details on my website at jkmathematics.com/plus. If you have any questions, please let me know in the comments. But if you don't have any questions, this is all I had for now. So I will see you next time.